Morning, everybody. Our second lesson for the probability distribution unit is a particular topic that's called binomial distribution, Bernoulli Trials. Now, Bernoulli is the actual gentleman that came up with this theory. Let's hone in on dissecting the words binomial distribution. We know, based on our knowledge after the first lesson, that a probability distribution requires us to look at all of the outcomes and all of their associated probabilities. Every single outcome possible and each outcome's associated probability. The word binomial, we know mathematically means two. So what's cool about all of the examples and all of the questions that we're going to look at today is that, yes, they're a probability distribution, but they're a special probability distribution. They're a probability distribution with only two outcomes. Only two. No more than two. Two and exactly two. Okay. Let's take a look at a little example here. We're going to start with a standard deck of cards. Okay. And we're going to play a game where we draw out a single card from the deck. We look at it, and if we draw a face card, we're considered a winner. If we draw a numbered card, that means ace through 10, we're considered to be losing. Now, we know based on our knowledge from the previous unit that the probability of drawing a face card is 12 out of 52. And that means that the probability of drawing a numbered card is 40 out of 52. Okay. We're going to call the probability of drawing a face card probability of success. And we're going to use the lowercase p to denote it. We're going to call the probability of drawing a numbered card lowercase q, and that's going to be our probability of failure. So the idea is we draw a card. Oh, numbered, I fail. Oh, face card, yes, that's a winner. That's the idea. Now, what we have to take a look at is that each trial, every single time I draw a card from the deck, and this is considered a trial, is completely independent. It's independent because not only am I returning the cards back into the deck after I look at them, but each trial is independent of each other, meaning that the probability of success will always be 12 out of 52. And the probability of failure will always be 40 out of 52, regardless whether I choose a face card and then I go in for another selection. Each trial is considered an independent trial. Now, for our game, we're going to continue to draw cards and record our successes and our failures. And every single time I draw a card, remember, I'm calling it a trial. Bernoulli trials are repeated. And the key to a Bernoulli trial is that there's only two possible outcomes. Face card, success, numbered card, failure. Again, to reiterate one more time, this is considered a binomial distribution because there are only two outcomes. Face or not face. That's all we're looking at. Okay? Now, let me explain how this works. You know, with some of our lessons, I'm usually used to having an audience, and I get volunteers from the audience and, whatnot. And in our video lessons, we've had to sort of pretend. Well, we're going to do the same. I'm going to pretend to have 3 students. We'll call my students Dan L, Mark I, and Mickey S. And each of those students are going to get 3 selections, 3 trials, 3 draws from the deck. Okay, let's take a look. Student number 1 is Dan L. Student number 2 is Mark I. Student number 3 is Mickey S. And student number 4, we'll do a 4th and we'll call her Jody M. Okay, so we're going to let Dan come up and we're going to let Dan do his first pick. Ooh, he got a jack. Yay, that's a success. He puts it back in, shuffles up the deck, does a second pick. Ah, bummer, 7, failure. Does a third pick. Ah, 7, failure. So Dan ended up with 1 success. Okay, Mark I comes up. He picks. Oh, wow, he got a jack. Picks again. Oh, 4. Picks again. Oh, 4. Isn't that crazy? 1 success. Mickey comes up, and Mickey's gonna pick jack. Is this kind of crazy or what? 4. Oh my god. I'm gonna have to really shuffle them up. Queen, yay! Mickey got 2 successes. Now, we're gonna pretend for Jody that